Right, so thought I'd do another video going through a paper. This time I've chosen the AQA paper from Thursday, 8th of June 2017. No better reason really, other than the fact that a whole lot of my classes were given it last week. So if we have a look, first question just asks us which unit is most suitable for the measuring the length of a tennis court. Well, millimetres definitely too small, would have a huge answer. Centimetres, similar really. So it comes down to metres or kilometres. Now kilometres we generally use for measuring the distance between different places, so metres is our choice there. Circle the multiple of both 8 and 12. Now multiple means multiplication table, effectively a number in the multiplication table of 8 and 12. If we was to list those, the first number that would appear twice would be 72. We go 8, 16, 24, 32, 40, 48, 56, 64, 72. And we do similarly with 12, 24. See, 24 is there twice, but it's not in our list. 36, 48, again, it's there, but not in the list. 60, 72. So it's not the lowest common multiple, but it is a common multiple of 8 and 12. What is 3 over 2 as a decimal? For this, we've just got to work out what is 3 divided by 2. Half of 3, 1.5. Okay, next one says circle the correct statement. So these ones here, these inequality symbols, when they're written, this value is the bigger of the two, this value is the smaller. If you've got an equals, like a double line like we have here, it means it can be equal to it. So I'm immediately going to reject those because there's no way 1 can be the same as -2 or -1 could be the same as 0. So it comes down to these two. Which one is correct? Is -4 smaller than -3? And then because the symbol's the other way here, is -6 bigger than 5? Well, the correct statement there is that -4 is smaller than -3. The temperature -4 is obviously colder than -3. This statement here makes no sense. How can -6 be warmer than 5 degrees? Next question asks us to use a calculator to work out an answer as a decimal. So I'm quickly going to whip up that calculator. We need to work out this square root. The square root of 701. So here we go. Now we put that in and you see it comes up with square root 701. To change that to a decimal, we use that SD key. We've got 26.47644459. So 26.47644459. Next one says give your answer part A to 1 decimal place. So we're looking at the 1 decimal place and we're considering the next number along to decide whether this needs to stay as 26.4 or become 26.5. Now because the 7 is 5 or above, we will be rounding that up to 26.5. Question 6. A swimming pool has 3 changing rooms, male, female and family. The pictogram shows the number of people using each changing room during 1 hour. First thing I need to do, using the information that 8 people use the male changing room, is to figure out the key. So if these 2 represented 8, they must represent 4 each. Next I need to say how many people use the female changing room. Well, I know that each one of these is 4, so that's 4, 8, 12, and then because this is 3/4, 3/4 of the whole shape, each one of these is worth 1. So I've got 4, 8, 12, 13, 14, 15. Finally, the manager has bought lockers for the changing rooms. Why should she not use these results to decide where to put them? Well, the issue is that she's only actually looked for 1 hour, which means if she's looked at, say, I don't know, 10 till 11 o'clock in the daytime, it's probably not going to show who uses the pool in the same way as maybe at the same time as, say, 4 to 5 o'clock in the evening, when we might expect to see more families because the children have finished school and things like that. So I would suggest something like it's only observed for an hour. So it's not going to reflect the whole day or not reflect kind of daily usage. Okay, question 7, list of numbers, work out the median. So for the median we need to put the numbers in order. A good practice for this can be to write the numbers out underneath the set of numbers that we already have. And that way we ensure that we don't miss any out. We then look for the middle. Now if we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, 9 plus 1 divided by 2 is going to be equal to 5. So the fifth number is what we're looking for. Alternatively, of course, you can cross off 1 from each side and so you're left with 1 in the middle. Okay, question 8, here's a map of the town. Question 8, part A, asks us which place is exactly northwest of the station. So when we're at the station, we look for the direction northwest, which if we fill this in on our compass is perfectly diagonal that way. So we're following that perfect diagonal till we hit the library. Question 8b, circle the 3-figure bearing of the monument from the park. So this means we're going from the park, which means we're standing at the park. We're facing north because our bearings always start from north. And we need to figure out what angle we need to turn through so that we're facing the monument. Now remember, bearings are always measured clockwise from north, so that's the angle we're turning through, which is precisely 180 degrees. Now, 8c, what is the distance in metres from the cinema to the station? So the distance in metres from cinema to station would require that I measure this. Now, since I haven't got a paper copy, I'm just going to go with what I gave out to my students, which was an A5 paper copy. Now, measuring the distance from cinema to station in a straight line, like that, you've got 3.8 centimetres. Now, our scale up here says that 1 centimetre represents 200 metres, so we then need to multiply that 3.8 by 200 to end up with 760 metres. Question 8d says, why might the shortest walking distance from cinema to station be greater than your answer to part C? Well, this is where reality kicks in. We may not be able to follow the exact straight line. Because of things in the way. There we go. Question 9 required that we complete the bank statement, probably most easily done with a calculator on board. So we've got our starting balance of £212.48, and we're then required to pay some council tax from that. So we take away 128.39, 128.39, and we end up with £84.09. So that's what goes in there. Now, the next thing that's going to happen is we actually get paid. Hooray, everybody loves a payday. So that money, our salary, is going to go onto and add onto our balance. So we're going to add the 856.21 to end up with 940.3. Now, important thing with money questions is that when we've got a single decimal place, to remember that we have a 0 on the end there. We always write money with 2 decimal places. Question 10 says the average age of teachers at school is 36 years. Mr. Smith's age is 11/9 of the average. How old is Mr. Smith? Now, 11/9 being a weird fraction doesn't change the fact that the rule is divide by the bottom, then times by the top. So 36 divided by 9 gives me 4, times 11 gives me 44 years. Now, the next question requires that we solve an equation. A couple of different ways to do this. I think I'm going to go with the lovely tried and true balancing method. So I'm aiming to get these x's on my own, so the first thing I'm going to do is add 3, as that will remove the minus 3 that's here. I of course have to balance that on the other side of the equation. So 14 plus 3 is 17. Now, this is the tricky bit, because now I need to work out what I times 4 by to make 17. And 4 times 4 is 16, but 4 times 5 is 20. 17 isn't going to be a whole number. So what I'm going to do is I'm just going to divide down by 4, either on my calculator or if I'm doing it in my head. Half of 17 will be 8.5. Half of 8.5 will be 4.25. Feel free to check that on the calculator or do that on the calculator when you do the paper yourself. On a calculator paper, don't rely on your numeracy unless you're 110% confident. Right, question 12. Lee sells ice creams. Table shows the midday temperature and his sales for the 5 days. He draws a scatter graph and a line of best fit. He's drawn, there is 2 mistakes. We've got to identify 2 mistakes he's made. So, first and most obvious thing to look at is the scales, but observation of the scales, it goes 0, 5, 10, 15, 20, 25, 30, that looks good. 20, 40, 60, 80, 100 and so on, that looks good. So there's no problem with the scales. What about titles? Well, actually, we've got a graph title, we've got axes titles, there's no problems there. So the first mistake that kind of shouts at me is that line of best fit. A line of best fit should be just that. It should be kind of best fitting the data. It should be trying to follow the information that's there, and it's obviously an issue because it's not doing that in any way. So I'd write that maybe the line of best fit doesn't follow the data. Okay. Some people want it to go through the point 0, 0. That is not necessary. So long as it follows the data, like this one that I've kind of sketched in dottedly, wouldn't go through 0, 0. That's not a problem, but it has to follow the data. Now, mistake 2, having checked out the axes, spotted the line of best fit, the only place we can really have an issue now must be in the coordinates he's plotted. So let's check those through. 30, 180, the first point is correct. Day 2, 26, 150. Again, nothing wrong with that. The third point, however, day 3, says 1780. Well, 17 should be here and 80 should be here. So we can actually see that he's plotted that point in the wrong place. Okay, so this coordinate is wrong. So maybe we should just note day 3 is 1760, not 1780. Or words to that effect. 12b, Lee wants to work out the range of the 5 temperatures. His calculation is 30, take 20. Is his method correct? The range is the biggest number, take the smallest number. The biggest number in my temperature list is 30. The smallest, however, is 17. So what he's done wrong there is he's done the first, take away the last, whereas what we should have done is the biggest, take the smallest. So we can say, no, he's not correct there. The table shows Lee's costs, work out his profit. So profit is always earnings minus costs. Now this is all still relating to this very same question. It's all relating to this information that we've got a scatter graph for. So at this stage, what I'm going to do is I'm going to work out his earnings. So his earnings are this bottom row, the scatter graph. There is sales over the 5 days. So I'm just going to make sure I add those up on my calculator to get the total sales of £660. Okay, so 660 but minus how much? Well, his costs are a little bit more complicated. We've got fuel costs and we've got ingredients costs. So the fuel costs, quite simply, £7 per day for 5 days would be £35. His ingredients cost, I need to find out what 15% of his sales are. I reckon I can do that in my head. 10% would be 66, 5% would be 33, put those together, we get 99. So all told, 99 plus 35 is £134 worth of costs that we need to take off there. Subtracting 134 from 660 will give me £526. There's his profit. So lots of steps to that question, but bear in mind, you've got that 660, you've probably got one of those 5 marks. You've got that 35, you've probably got one of those 5 marks. You've got that 99, you've probably got one of those 5 marks. So you've subtracted cost from earnings, you've got one of those 5 marks. So it's always worth going with things, even if you don't know all the parts, because there'll be bits for correct answers and stuff like that, correct parts in such a big question. Okay, question 13 requires that we work out the size of angle X. Now we've got here angles round a point. One of my students in lesson the other day attempted to use the straight line here, which actually on this big board I can see isn't straight, but I can see why when it was reduced to A5 it looked pretty much straight. It is, however, in fact only 181 degrees underneath it, so it's slightly over, it's slightly reflex. So these 3 angles here will add up to 179. Alternatively, I can just take them all from 360. So I've got 126 degrees to come away from that, which leaves me with 53 degrees. So, knowing that one's 90, knowing they add up to 360, we will get a correct answer. Okay, question 14, use the fact that 1 kilogram is 2.2 pounds, the fact that 1 stone is 14 pounds, to change 70 kilograms into stone. Well, 70 multiplied by 2.2 is 154. Now, 154, how many 14s are 154? Well, I know that 10 makes 140, then I've got one more. So 154 divided by 14 will give me the answer 11. So what I've done there, 70 kilograms is 154 pounds, because every kilogram is worth 2.2 pounds. And then 154 pounds divided by 14 gives me 11 stones. So question 15 says here are some numbers. We've got 10, 13, 15, 20, 27, 39. It then says 10, 15, 20 is an arithmetic progression. Use 3 of the numbers to make a different arithmetic progression. Describe the rule. So I suppose we could go, so an arithmetic progression is a number that goes up by the same amount. So if we look at the numbers and going up, we could go 10 to 3 is 30, 10 plus 3 is 13, 13 plus 3 is 16, not in the list, so can't use that. 10 to 5 is 15, 15 plus 5 is 20, is this sequence they've already given us. Let's then try 10 to 20 is plus 10, plus another 10 is 30, we've not got that, and the next number is going to be too big. So let's start at 13 instead. 13 to 15 gives me 2, so plus 2, plus 15 plus 2, 17, that's not there. 13 to 20, however, is plus 7, and then 20 plus 7 is 27. So I could have 13, 20, 27. The rule is add 7 each time. I suppose if you were really cheeky, you could, if you've got the guts to try this, you could have maybe gone for 20, 15, 10 and see if they give you the marks for that and said take 5, but I think I'd rather be on terra firma and give a definite arithmetic sequence. Right, or a definitely different one. Question 16, counters of bag of red or blue, 1/5 of the counters of red, work out the ratio red counters to blue counters. Simplest amount to divide into a fifth would be 5. It tells me I've got 1 red and 4 blue, or 1/5 of them are red, so 1 out of 5 is red, the rest are blue. Writing that out, 1 out of 5 is red, the other 4/5 are blue. We can see we end up with a ratio of 1 to 4. Question 17, circle the fraction equivalent to 0.1%. So this question caught a lot of people out. Now 1/10, if we think of it as a percentage, is 10 out of 100. That's 10%. 1 out of 100 is obviously 1%. So it kind of makes sense that if we're dividing by 10 there, 10% divided by 10 makes 1%, because we've got 1/100th from 1/10. But the next one is going to be our 0.1%. It's 1 out of 1,000. Because the numbers are following that pattern. Question 18, Ellen works for a company that sells cars. Her monthly pay is a salary of £1,470, 28% of the total profit the company makes from her sales, and a total £250 bonus if she sells at least 15 cars every month in that month. So the table then shows some information about the cars she sold last year, how much the company kind of paid out for the cars she sold, how much she made from the cars she sold, and the number of months in which she managed to sell at least 15 cars, so we can work on that bonus. Was Ellen's total pay for the year more than 40,000? So her total pay for the year is going to be based on, well, these three things, isn't it? So there's her salary. How much has her salary been across the whole year? So to do that, I need to take her monthly pay, 1470, well, times it by 12, because she gets that every month. So she gets £17,640 on salary. We've then got kind of, I suppose, sales kind of bonus thing, which is 28% of the profit the company makes from its sales. So we need to work out, first of all, what the profit is for the company. So the profit for the company is going to be that £538,000 that she's made for them, minus the 464,500 that it's cost them to buy these cars in. So that's 73,500. That's the company's profit, and then I need to work out 28% of that. The easiest way to do that is to times by 0.28. You could, however, do it by dividing by 100 and timesing by 28 if you preferred. So we've got £20,580 of sales money. Finally, we've got her bonus, which is £250 if she sold at least 15 cars that she did 3 times. So she received that bonus 3 times. 250 times 3 is £750. So what we need to do now is we need to add up her salary, sales payments and her bonus and see, does that money exceed £40,000 a year? So let's work that through. So the 20,580 is already there. Let's add that salary, 17,640, and that 750 bonus, and we can see it's 38,970, 38,970, which is not more than 40,000. Remember, we will need that kind of final statement. Those 6 marks there, one of those will be for saying, no, this is not more than £40,000. Okay, Ben and Katie throw darts at a target. Ben's ratio of hits to misses is 5 to 1, whereas Katie's is 3 to 1. Ben says 5 is bigger than 3, so I must have more hits than Katie. Right, the point is here that these ratios could have been simplified. So Ben's ratio of hits could have been 5 to 1, so he could have just taken 6 shots. Whereas Katie may have taken, well, hers starts at 3 to 1, but that could have been simplified from, say, 6 to 2. So if Katie took 8 shots, we say Katie took 8 shots and hit 6 times, then this is more than 5, yeah? So although he's hit a higher proportion of the time, if she's had more shots, she's still hit more times. Question 20. Code has 4 digits. Each number is a digit from 0 to 9. The digits may be repeated. The code starts 541. Joe chooses a number at random for the last digit. Write down the probability he'll choose the correct number. So which numbers could it be? So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. 10 different numbers, one of them is correct. Now Amy, on the other hand, knows that the last digit is an odd number, but isn't 7. So she chooses one of the other odd numbers at random. What is the probability that she chooses the correct number? So we now know that this correct digit has to be 1, 3, or 5 or 9. It's an odd number, but it's not 7. So she can only pick 1 out of 4 numbers. Question 21. Eva thinks she can save water by having a shower instead of a bath. Eva's shower uses 10.8 litres per minute for it lasts for 8 minutes every day. Eva assumes that the water in her bath is in the shape of this cuboid. 1,000 centimetre cubes is the same as 1 litre. Using Eva's assumption, work out how many litres of water she saves by having a shower instead of a bath. Definitely going to want a calculator for this one. So, first thing we could do with working out is water usage in the shower. So her shower uses 10.8 litres every minute, and she's in there for 8 minutes. So if we times 10.8 by 8, we get the number of litres. So a shower takes 86.4 litres. So then, the second thing we need to know is a bath. How much water, how many litres does a bath use? Well, she's assuming that her bath is in the shape of this cuboid. So we need to work out how many litres are in that cuboid, which is kind of tricky. So first of all, we've got this conversion. 1,000 centimetre cubes is 1 litre. So if we can work out the centimetre cubes in the bath, we can use that to work out the litres in the bath. So 110 by 50 by 35, the volume of that cuboid, that's how much she assumes is in her bath. Divide this by 1,000, because every 1,000 of those centimetre cubes is worth a litre. And we can see that a bath is 192.5 litres. So how many litres of water she saves using her assumption will be the difference in those numbers. So we need to do 192.5 less 86.4. Okay, and that gives us 106.1 saved. Part B is a bit of a weird one. A shows the water level before Eva gets into the bath. So what they're saying is this is what Eva's bath looks like when it's full of water and ready for her to get in. B shows her cuboid. The cuboid we've just assumed is holding all the water we need for her bath in the empty bath. So what we can see by making comparison from A to B is that the cuboid actually holds less water than her real bath. So because we've assumed that the cuboid was full of water when we've worked out this 106.1 litres saved, the amount of water saved is actually more because there is less water in our assumed cuboid than there is in the real bath. Question 22, we've got a bit of Pythagoras theorem. Work out the value of x as a decimal. So we're working out a shorter side because it's one of the ones next to the hypotenuse. So we square the numbers, we take and we root. Now I want it as a decimal, so I can't do this with a surd or in my head. I'm going to have to just type that in. So it's given us root 55, but we want a decimal, so the SD button is our friend. 7.416198. And so on. So let's just round it to a couple of decimal places. 7.42 centimetres. So question 23, Lily goes on a car journey. For the first 30 minutes, her average speed is 40 miles per hour. She then stops for 15 minutes. She then completes the journey at an average speed of 60 miles per hour. The total journey time is 1 hour. Draw a distance time graph for the journey. So first 30 minutes, travelling 40 miles an hour. So after 30 minutes at 40 miles an hour, because 30 minutes is half an hour, she'll only have covered half of an hour's worth of distance. So wishing I had a ruler with me, I'm just going to jot that in as best I can. So that's the first part of her journey. After this, she stops for 15 minutes. So we take that through to 45. She's not actually covered any distance because she's sitting, she's having a rest. She then completes the journey at an average speed of 60 miles per hour, so that the whole journey takes an hour. Now, if we're travelling for 15 minutes, 1/4 of an hour, at 60 miles an hour, we're going to travel 1/4 of 60. So 1/4 of 60 is 30, 15. So she's going to go 15 more miles. So from 20 miles plus 15, she's going to go 35 further miles. 1 mile every minute. So that's how 60 miles an hour works. So that's the distance time graph for the journey. We're now required to write down the average speed for the total journey. Now the average speed is always total distance over total time, which is very easy because the total time is 1 hour. So the total distance was 35 miles, but that's divided by 1 hour. So that's 35 miles per hour. Okay, question 24. The pie chart shows information about the voters in an election. 3,360 more women voted than men. Work out the total number of voters. Right, so let's break this up. So that's 110 degrees for the men. We've got 110 degrees is kind of that's part there, and then what's going to be left? So we've got 220 degrees left from our 360, or taken from our 360. That leaves us 140 degrees remaining. Now this 140 degrees, the reason I've broken this like this is because I want to know, or I've got the information about how many more women voted than men. So I need to know how much more the angle is for women, because that angle will represent these extra voters. So we know that 3,360 voters was represented by 140 degrees on this chart. At this stage, I'm going to grab my calculator again, and I'm going to do 3,360 divided by 140, because that will tell me what 1 degree was worth. So in other words, 24 people are represented in 1 degree. Now obviously our full pie chart is a full 360 degrees. So now we multiply 24 by 360. That's our voters, 8,640. Check I've got that right. Yeah, that's right. Good. So here we are on question 25. Table shows information about some CDs, type, rock, pop, jazz, number of CDs, 2x, 2x plus 5. A CD is chosen at random. Probability it is rock is 1/20th. Work out the probability it's jazz. So we know that 1/20th of the CDs involved represented by 2 CDs. So if 1/20th of the CDs is 2, that must mean that, well, 1/20th is 2 out of 40, isn't it? So there's 40 CDs altogether. So 2 of those are rock, so these 2 groups represent 38 CDs. Now that we know that, we could say, right, so that x plus the 2x plus 5 represents the 38 CDs. That tells us that 3x and 5 is 38. When we simplify that, take the 5 away. 3x is 33. Then we divide by the 3 to get 1x. Divide by the 3 to balance is 11. So we know there was 11 pop CDs, and then 2 times 11 is 22, plus 5 is 27. So there was 27 jazz CDs, 11 pop CDs, 2 rock CDs. Probability it's jazz. I've done all the hard work, I've just got to write that probability down because that's my overall aim, is 27 out of 40. Question 26, complete the table of values for x squared minus x minus 2. Got to be careful doing this in a calculator paper because if you do not use brackets around those negative numbers, you will not get the right answer. So if I put minus 2 in brackets squared, minus brackets minus 2, okay, and then minus 2, and press equals, I get the correct answer, which is 4. Just to show you what happens if I don't use those brackets. If I don't use those brackets, if I go minus 2 squared minus minus 2 minus 2, I get the answer minus 4, which is obviously not correct, or is not correct. Not obviously not correct, but it isn't correct. Because what the calculator is not doing is it's not squaring the negative number, it's squaring the 2 and then making that answer negative. As a rule, you can always replace the letters in a formula with the value in brackets. So I could go -1, close bracket, squared, minus open brackets, -1, close brackets, minus 2, boom, answer 0. And I can do this with whole numbers, with positive numbers as well. So I could go back here, and rather than having to type the whole thing out because I need to put the number 2 in, I could just go, right, let's get rid of that -1, put 2 in there. Get rid of that -1, put 2 in there. Happy days, the answer's 0. We were also getting that expected symmetry from the quadratic graph. I will just take a moment, for those of you who've got these Casio calculators, to point out there's a lovely little table mode that can be used to do this. If you press that mode button and press table, you'll see it comes up with this fx. And we can use the alpha button to actually type in the letter x that will be treated now like a formula. So if it's x squared minus alpha x, press -2 and go, right, there's my formula, I want to put numbers in. It says, right, what x number do you want me to start with? So I look at my table, and I can see I can put -2 in there for the start value. Right, it goes, what x value do you want me to finish on? And I can see the last x value I want is 3. It goes, what do you want me to go up in? And I can see that those values are going up in 1s, so I select 1. And it'll give me the table, and you should see, so -2 matches to 4, -1 matches to 0, 0 matches to -2, 1 matches to -2, 2 to 0, and 3 to 4. And so it's done it, and I can verify it because it agrees with the ones that are given to me. To get away from this, press mode, press 1, and you're back to normal. Right, we're then required to plot these values on the table, or on the graph. So we convert these into coordinates. This is the coordinate -2 and 4. So I go to x is -2, y is 4, I put a point. I go to x is -1, y is 0, put a point, 0 -2, 1 -2, 2, 0, and finally 3, 4. Now we are expected to know that these graphs follow a U shape, so they're not flat bottomed. They will carry on to go down a bit before they go back up. Okay, sometimes you will have a clearly defined bottom point that you can go through. That's what we're looking for. Okay, write these numbers in descending order. So we've got 9, 5, 6, 3. We've got 9.56 times by 10 3 times. So that's 9,560, which is a little bit smaller. And we've got 9.56 times 3 10 times. Let's just get a value for that, but I think it's going to be kind of huge. 9.56 times by 3 to the power of 10. Yeah, that's kind of big. 564,588. Let's just do 5645. It's hugest by a long ways. So we've got 9,560. We've then got 9,563, and then we've got. Oh, actually, I should probably put that as 9.56. What's happened there? This one should be 9.56 times 10 to the 3. Let's give it in the form that we've been given it. This will be 9,563, and then this one would be 9.56 times 3 to the 10. Okay, question 28 wants us to rearrange this formula to make x the subject. We've got two options on this, because it's a nice one. We can arrow diagram it. We can say x gets divided by 3. To give x divided by 3, we then add 9 to it to get x divided by 3 plus 9. Now the formula tells us that this is the same as y, so then we can work back. Y take 9 will give us y, subtract 9, and then we've got to multiply that by 3, and it's the whole thing, so we've got to put 3 and then brackets y minus 9. Everything's got to be multiplied by 3. So I've got x equals 3 times y minus 9. We could could also have done it by balancing. Y equals x divided by 3 plus 9. So our balance method wants to try and isolate the x. So let's isolate the x term first by getting rid of the plus 9, which we can do by taking 9. But this has to be balanced on the other side. So we know that y take away 9 will give us the same as whatever x divided by 3 gave us. We then need to get rid of the divide by 3 to get the x on its own. So we times by 3 to get rid of that. And again, we have to use those brackets, or alternatively, multiply both terms by 3 to counteract the fact that we want to get rid of that. Okay, question 29, last on the paper. Use trigonometry to work out the length x. So if we look at that, we can see we've got the hypotenuse, we've got the opposite, the adjacent just here. So the hypotenuse is always the longest. We imagine we're stood in this angle. The one we can't touch, because it's the opposite to us, is the opposite. The other one we can touch that we haven't called hypotenuse is the adjacent. So in this problem, we are using a hypotenuse and the angle to work out the opposite, and we are not bothered about the adjacent. So we then bring in, ooh, that's fun, sum, cat, toa. So the one which has O and H in is the sine function. We're trying to work out what O is, so I cover up the O, I cover it up to get sine of the angle times by the hypotenuse. So I do sine 72 times 8. Boom. Grab a calculator and let's go with it. So it's 8 times sine 72. 7.608, 7.61. Now, when I look at that, I always just want to check out, does that make sense? This is 7.61, which is pretty big compared to the slightly larger hypotenuse. Does that make sense? Well, if this angle here is 72, that means that this angle here is 18 degrees, because the angles have to, all three, make 180. That 72 is a lot bigger than 18. So I feel safe that the 7.61 will be pretty close to the hypotenuse, and I'm happy I've got the right answer.